Okay, good morning, everyone. Welcome to the training of our MEC topic. My name is Daniel. My surname is Hu, so you can call me Daniel. Today, I will spend about 1 hour to give you the brief introduction of a very popular technical concept about MEC. Okay. So this is our materials about MEC slides. So according to the topic, MEC, the first question from you, most of you, will be like, what is MEC, right? What is MEC? So from this name, we are already able to know the MEC stands for mobile edge computing, right? Mobile edge computing. So the next question is, what does the mobile means? What does the edge means? And what does the computing means? So here, from these slides, it gives us the same questions from our minds. So let's start with the introduction of these three letters, MEC. So first, M stands for mobile, right? Sorry, for mobile in the beginning. But right now, along with the evolution of the network, so it becomes to multi-access. So the multi-access means more access technology, not only mobile, but also the other like the Wi-Fi, like fixed access technology or scenario, like mobile, right? Like the other enterprise or stadiums, many other access scenario. So the M stands for multi-access for different kind of the users, different kind of the enterprises, users, consumers, any one of them. So this is the meaning of M. Edge, okay. Edge means this MEC solution is particularly applied or deployed on the edge position of the network. So you may have the question, why we will deploy such a network identity or solution at the edge of the network, right? This is maybe the question from most of you. So speaking of the edge, I need to clarify some basic concept of our network. So here, I will draw a network. This network is for a user, okay? A terminal to access, to use what kind of service? Use some like internet or intranet. Or so we have some other professional terminology to describe as CDN, which means content delivery network. So very typical example, like we are going to log onto the gaming server station, or we are going to access to the YouTube server. We are going to access to some enterprise office network to use the application from this right? So all this refers to the PDN, right? PDN, public data network. So this PDN is can include all the target function application that we want, but they are not deployed. They're not built by carrier. They are built by the enterprise, right? By the service provider. But here we have another network. This network, give me a sec. Yeah, okay. This network is deployed by carriers, like TDAR, right? Like China Mobile. So if a terminal or users are going to access to the PDN, sorry, the equipment has some issues, okay. To enjoy the gaming, to browse the web page, to download, to watch the online video, we need to access to the carrier network first. Then, by means of carrier's network, then we are able to access to the target PDN network on the right part. So here, for example, we have a wireless access network, right? Use the wireless signal and access to the carrier's network. And then here, access to the PDN. So this network, we have another name, core network. Core, okay, core network. This core network is particularly work for PS, packet service, okay, packet service, because all the internet service, all the data service refers to the packet technology by IP package delivery. So here, in this core data network, we have some network identities. One of the network identities is responsible for the registration of the user, which we call AMF, right? So when the users access to the network, register the network, we need AMF to responsible for the registration. Besides that, we need another two network identities like SSMF and UPF to perform the data transformation. For example, let me use another color. The data traffic from the users to the PDN target network will go through this way. And then finally egress outbound to the PDN network. So you're able to know, are you able to see that the PS core network function is to perform this, to perform the data traffic forwarding from the left, from the user's premise to the target PDN premise, okay? So this network identity, UPF, user plane function, is particularly work for the data traffic forwarding. Okay, so let's imagine another scenario. First, the PS, package service core network identities or equipment usually deployed in some capitals of the province in some big countries, or in some small countries, we will deploy these network equipment in the capital, right? In capital, for example, in Abu Dhabi. But some other users, they will access to the network at some small city, for example, here. On another city. On a small city, the data traffic will go from the other city wireless access network and then routed to the capital city network. Use the capital city's network identity UPF, then go to the capital city PDN network. But what if the PDN network application deployed on the here, for example, here, we call it LDN, local data network, which deploys some local office application, local office server. So your purpose is here. Your target is here. Your objective is here. But you still need to send data traffic around, go all the way to the capital city, and then outbound and backhaul to the local data network in the local city. So this distance, for example, 100 kilometers, and here this distance, another 100 kilometers. So 200 kilometers will cost some extra time delay, right, for the data traffic. So we have an idea to deploy another user plane function network identities on this city, on the city that you perform the service. So we can go like this way to reduce the transmission distance, to reduce the time delay, to make the service visit more fast, and also reduce the transmission resource consumption, right? So from the point of view of this core network, these UPF network identities are in the edge of the core network. That's the edge we indicate here. That's the edge that we indicate here. So the purpose we deploy an MEC solution on the edge of this network is in order to reduce the transmission resource is to reduce the time delay to improve the user's experience, right? Also, in the case of the edge solution, we can also achieve or satisfy some enterprise needs. For example, to localize the service traffic of this company in a specific area. So this will make the enterprise data traffic or data more secure, more safe, not necessary to expose to the external network, all right? So localize the data, the user's data in a specific area. Okay, so we have known what does the M means, multi-access. What does the E means, edge? Edge, network edge, user plane function means. Then let's check the point of C, computing. So all we talked about is the network function. Network function is like a pipeline to deliver, to transfer the user's data traffic from one end to another end. But why will perform some like computing function to the user's service? This computing function usually not the work of the carrier's network. It's usually the work of the PDN network, of the office network. Like here. For example, in the CDN, in the content delivery network, we can deploy some like gaming, right? Gaming application, some like AI, okay? Intelligence, artificial intelligence, like analysis. They are all the application, they are all the servers in the CDN network. So these are not the job of the carrier's network, not the job of the carrier network. But why we will talk about the computing function in the MEC that deployed by carrier network? It's because we want to reduce the distance between the carrier network identity UPF and the CDN or the LDN. We want to reduce the, for example here, we want to reduce the distance between them to improve the user's service, visit, time delay, or some other experience more perfect. So our idea is to make the LDN application up on or on board, okay, on board to the UPF platform. Okay, so finally, after the integration of the UPF, the carrier's network identity, and the LDN application performed by CDN, we merge them together. So this is perform the computing function, and this is perform the multi-access and edge function. So together, we can define this kind of the solution, integration solution as MEC, okay, MEC. So after the introduction of these three letters, MEC, now you will have a brief concept, brief idea about this thing, okay? So the MEC is this solution standard is defined by a standard institution named ETSI, okay, ETSI, this Euro Telecommunication Standard Institute, okay? So this solution is developed, is researched in very have long time research phase from like 2014. And in 2017, the standard has been freezed, okay, has been freezed. The basis, technical basis of the MEC solution frozen is because we we invent a concept or technology, CUPS, okay, CUPS. The CUPS stands for, control, user plane, separation, okay, separation. So what does this controller and user plane separation? Okay, so this is the 5G core network architecture, AMF, SMF, and UPF. But in the 4G period, the core network is performed like this one. Here, we have another name, MME, and here we have another name, UGW. So this signaling, this dot line means signaling. So the signaling message is processed by MME and UGW controller plane components. And this user plane function is performed by UGW user plane component. So in the 4G period, they are they are integrate one network identity. But when we involve the 4G to 5G, we separate the controller plane function and the user plane function into two different network identity, which is the UGWC turns to be SMF, session management function, and the UGW turn to be UPF. So this is we call it CU plane separation, the short name CUPS. And you already know the UPF, the separated user plane function, is one function or one component or one network identity of the MEC solution. So without CUPS, we have no MEC solution. MEC solution is based on CUPS technology. So that's the point of the CUPS in the development of MEC standard research history. So after we fix the user plane function separated from the origin network identity UGW, besides that, we have another idea that we make the target CDN, LDN, or PDN application network on board to the UPF platform. So these, from now on, in recent 2 years, we developed our new standard of the application on board here, this one. So from this complex MEC architecture, you are able to see the data plane, okay? Data plane. Let me use another color. Here. This data plane means the user plane forwarding function, right? UPF. You can consider it as UPF. So like I said, UPF is only one function, one component of MEC solution. So what else of this MEC solution that we can fulfill, we can realize to make the MEC have the computing function? Okay, here. APP, you see, application. So the application stands for the computing concept. So UPF application. Together, we have the initial architecture of MEC. But only the application deployed on the UPF platform is not enough. It's not enough. We also developed another new component to support the application running on this platform, which is here, MEC platform. MEC platform. This MEC platform is the component to support the application running on this platform. For example, application registration, okay, application governance, application life cycle management, or of the management job for this application on this platform will be performed by this MEC platform. So there we have another short name for this component, MEP, okay, MEP, MEC platform. So this one, these three basic components comprises MEC basic solution. On the right part, we have another two supplement component is MEC platform managed. Sometimes we call it MEPM. MEPM. And also here, MEC orchestration, MEO. So this is work for the orchestration. So these two supplementary components are very similar to another two components, NFVO and VNFM in our NFV solution or NFV architecture. Okay, so let me summarize this architecture, or let me simplify this architecture by whiteboard drawing. Okay. So first, we have a UPF. We need to deploy or install. Then we will deploy or install another component, MEP. And under help of the MEP, we can deploy many applications. For example, APP1 or APP2 or APP3. So all these onboarded application should be registered on this MEP platform. And also, if the application are able to visit the service from some other application, they can discover each other under the help of the MEP platform. This mechanism we call governance, okay, governance. Okay, governance and registration. So the MEP is the guy work for this kind of function. Then we have the MEPM here and the MEO here. So we can compare this component, like I said, with the NFVO and the VNFM. The application we are going to deploy on this platform the configuration template and the file, the software of this is the descriptor, right? APP descriptor, which is the template of the specification of the application, and also software, and also image file. We'll also upload this to the MEO and use the MEO to orchestrate, to analyze and deliver and send to the MEPM. And MEPM will send these commands, send these requests to the platform and transfer to the MEP to authorize, to ask the MEP to deploy, to install the application. So this is the job of these two components, MEO and MEPM. So overall, this drawing is the point of the MEC architecture. And also this platform is composed of the server, right? We have a lot of the server, the hardware, right? Servers. And on the server, on the group of the servers, we will install like cloud operating system. And on the cloud operating system, we will deploy some like virtual machines, like containers to install the UPF component, to install the MEP component, also to install the applications. So the platform infrastructure refers to these things, okay? So with the introduction, my introduction from this drawing, you are able to understand the basic points of these components from this architecture. And there are some also standard interface name defined by ETSI, like MP1. MP1 is the interface between the application and the MEP, right? And also MP2 is the interface between the MEP and the UPF. We can indicate here MP2 and here MP1. So MP1, the interface, is for MEP to manage the application, which based on this component. MP2 is the interface for the intercommunication between the UPF and MEP. The purpose of the UPF to connect MEP is that we have many supplementary extra function we can deploy on MEP. For example, DNS server. So the UPF will connect to the DNS server by MP2. Also, this UPF, we have many traffic steering policy will be configured on the UPF locally, or this kind of the policy can be configured here. And release or dispatch to the MEP, and MEP transfer or deliver to the UPF as well. Okay, so I think we will have a brief mind about this MEC solution and architecture. So this is the summarize or the conclusion of the standard that this standard ETSI, and also in the MEC solution, we have a network function UPF that is another network component invented or developed by another standard 3GPP. So the UPF is the overlap or the confluence point between these two network standards, 3GPP and ETSI. Okay, so after we get the point of MEC, then we can imagine in what scenario we prefer to use the MEC solution, right? We already know the MEC solution benefits or advantage. 3 ones. The benefit or the advantage. First, reduce the time delay, right? To perform the low latency. Two, to reduce the transmission consumption, right? Three, to make the application data localized, right? It means more secure, right? Security, according to some enterprise regulation. So this is the basic advantage of MEC solution deployment. So we have some examples of the service scenario, like video optimization. Imagine that we were deploying many CCTV cameras all over the park or the garden or the office area for the security service. For example, in the warehouse, in a storage house, or in some like equipment room. But you have the experience. Most of the time, the image that captured from the camera are static, right? Nothing difference. But normally we will upload all this image data to the monitoring center server. But as we know, this is not necessary. This kind of data traffic consumed and waste the transmission bandwidth and resource. So are we able to deploy some like small software or application to analyze the camera image? So for example, if there's some difference, there are people are like a dynamic scenario or some movement happened in the image, then we can trigger the video traffic upload. In the other case, if the image is static, we can keep the video data locally, okay, on the local server. And after a specific period, we can drop it, we can remove it automatically. So these kind of the mechanism or policy require a local small judgment or analysis application of software. So we can install this kind of the computing function on the MEC platform. This one, AR, augmented reality. So augmented reality is also another service scenario which are computing or create some extra content based on your camera image. So this also require the local computing function to reduce the time delay between the user's terminal or equipment and the server, the AR server. Also, like as well as IOV, interconnection of vehicle, right? Interconnection of vehicle. We will have many vehicles on the street, on the road. So sometimes in the cross, sometimes in the expressway, we have many scenarios of the traffic. So we can perform like detection, distance detection. distant detection in a large area, right? Also, we can perform fleet control. I have a small, very short clip of the video to show you like the vehicle. Give me a second.
Enabler for connected cars and driving vehicles. These kind of services will enable truly connected cars and driverless vehicles.
This is we call the fleet control.
The industry awareness about the importance of V2X is clearly gaining momentum and will be playing the key role in enabling car-to-car and car-to-network or infrastructure communication. The next generation mobile 5G network will enables end from any location. Is the future connects to the system and searches
like this.
for the best
this is the
available
fleet
platooning
control
options for the required destination. Once the best route has been chosen, a request is sent to the platoon manager. After getting the confirmation, the user will drive towards the platooning group and joins. Once the car wants to leave the platooning, it will exchange this information with the group and leaves. The exchange of data is at least with 10 milliseconds latency and message sizes of 50 to 1,200 bytes. For sure, the artificial intelligence in future cars can also automatically initiate and control platooning in the future. Through the V2X communication supported by the 5G network, vehicles can better evaluate the probability of an accident.
Emergency procedure on.
The system will coordinate maneuvers with less than 10 milliseconds latency and 99.99% reliability on all kinds of exchange data like video feeds, safety messages, and data from sensors. The collision avoidance system will bring much more safety for society and all traffic participants. With Huawei 5G.
Okay, so this is a very typical example scenario for our IOV, okay, IOV. Also for some other scenario, like, let me give you some more, like the, especially for the medical system, like in the hospital, we will have like this one. We all have the experience of the image medical diagnosis, right? For example, like the X-ray of your specific area of your body, and then the doctor are going to analyze the image on their computer. But most of the scenario, the image will upload to a center or an integrated platform, which we call AI. For example, this is the computer of the doctor. And here we have another AI assistant platform to analyze the image, okay, the image. In the first phase, in the first step, then feedback the diagnosis, the initial diagnosis conclusion to the doctor, and doctor will perform the second or the third diagnosis or analysis on this image, and finally give the conclusion to the patient. And we can deploy this kind of the application or this function platform on board to the MEC platform, right? And this data traffic will be transferred or forwarded locally. Many guys, you will have doubts or questions, because in many enterprise or like hospital, they will deploy the private network, the special network with the Wi-Fi, okay, the Wi-Fi or the fixed local network. They will not use the carriers. They will not use the carriers network because of the CapEx or OpEx. So we will have to give you the comparison between the like Wi-Fi in many enterprise network and the carriers network, like the base station. As we know, the Wi-Fi has some shortage. For example, the Wi-Fi bandwidth is only able to perform like 100 megabit bps. But this 5G, okay, 5G base station, 5G new radio are able to perform like 1G bps in theory. Also, the Wi-Fi power is not so strong. So make the Wi-Fi coverage is only like 30 meters. But our 5G coverage will be like 500 meters at least, or even 1 kilometer, right? And Wi-Fi has the shortage on the handover. The handover duration will be very long, like some seconds, but our new radio handover, right, will be in milliseconds. So for the Wi-Fi private network, the enterprise or the hospital need to arrange or need to maintain our specific technical team or division. But this core network, this carrier network solution, no need for the enterprise to maintain a specific team to perform this. You are only able to, you have just to give some like a rent, okay, or the other payment monthly to the carrier. So this is the basic comparison between the Wi-Fi solution and carrier network solution in some private network scenario for the hospital, for the school, right? For the campus, something like that. Okay, so this is the basic of the service scenario of the MEC. But one more point of these, or one more advantage of these MEC solutions is that we can perform here. We can perform the traffic steering in MEC solution. The traffic steering means, okay, so if we deployed UPF on the edge, okay, on the edge of the network here, sorry. So if your data traffic destination is local application or server here, okay, you can just go this way. But also we have some other scenario. Your data traffic are going to visit another application server on the other location. So you can go through the UPF, the edge UPF or MEC here, and steer to the other direction, to another UTF, then to the other application. So this one here, the steering function, we have another feature name, ULC. More freely, so we can make our data traffic go to the local destination or go to the center, go to the other direction. So this is also a, unique feature that our private network not able to realize. Can to use the MEC to obtain the image of these cameras locally. So all these service realization were no need to deploy the local network enterprise. We can just use the Keras network to deploy an MEC solution to make the data traffic go through the wireless base station. No need by Wi-Fi to have this kind of user experience. And also for some other like car racing circuit is the same, right? Cameras. And for some like drone scenario, like for the in the port, in the store, for the gantry crane, right? For the crane, like this. We can make the a driver of the crane in the office to operate the crane, like here, the crane here, right? The crane. By using the MEC to transfer to send the control signals and also get the cameras. Okay, we have the cameras. Like here. Crane. We have the cameras, we have the controllers, but the drivers is in the office in the part office to control this crane. So all this traffic, the video this traffic, the control signal traffic will be transferred locally in the port area. No need to send to the camera network equipment to reduce the time delay, right? So they are all typical commercial cases that we can apply MEC solution. Okay, so because of the time limitation, this content that I introduced is pretty much of MEC technique introduction. you for your listen, for your participation. Okay, so thank you. If you have any question, you can. Someone asked me, how does IoT relate to the edge computing? Okay, the IoT it depends. For example, as I know, the IoT were more used in the is more used in some like factory, right? For example, like here, like this kind of factory. In the factory, you will install many small equipment like the detection, the temperature detection, right? The camera, the movement detection, all these kind of the small terminals you installed on this big factory with massive access. So you can deploy the MEC, especially the UPF, locally in your factory equipment room. No need to use the UPF from the core network equipment room. So the data that sent from the detector will directly collect or forward by going through the UPF and finally sent to the factory monitoring center. So this will make the time delay. This very fewer to make the time delay as minimal as we can. So this is the benefit or the advantage that we applied MEC for the IoT scenario, according to my opinion. Otherwise, if without MEC solution, you have only two options. You can use the UPF from the capital equipment room. In that case, the time latency will be more than MEC. Also, you can deploy the Wi-Fi private network yourself. No need to use any carrier's network resource, but that will make your OPEX, your operation expense, and CapEx, your capital expense, higher, right? Higher than the MEC solution. So this is the IoT scenarios that I can imagine. Some other question, please elaborate that 5G UNR are implementing on the client premise or providing 5G facility through the nearest. Yes, that's a very good question. So, you know, usually on all the area in our like factory, like our port, like our office, like our garden, we will have the cell phone signal, right? So that means we will have the 5G new radio base station closely near to our garden or even in our garden. So we can just directly use this wireless resource to send our data traffic. So we don't have to new build or to ask the carrier to build a new tower of the wireless station to collect the data traffic local. That would be more expensive. Unless in this factory is in a very like in the desert, right, or in isolated area, there's no signal. Okay, in that case, you probably need to ask for a new tower to have the signaling coverage in this area. But it depends. The advantage of the CapEx OpEx is that we don't need to maintain the technical team in our company, in our enterprise. We can reduce this expense. We can just ask the carrier network to help to build our virtual private network by providing MEC solution, right? Also, another feature from 5G is the network slicing feature. So with the MEC, with the network slicing, most of the enterprise, they are able to build their virtual private network without any like equipment purchase, right? Without any technical team maintenance. All this kind of the job will be performed, will be responsible for the carrier network. So that's the benefit. That's the business network in future. Okay. Any other questions? You can. We have some left time for your question and answer. Yeah, because the MEC is a very big topic. We have only 1 hour to. I already have the give my effort to introduce more detail about this solution as I can. Like this slides is talking about the traffic steering that I mentioned. Yeah, only for 1 minute, because in this case we will have many different complicated scenarios to make the data traffic steered locally or to the other location, right? Many cases. Okay, so thank you all for the participation of this short training. Thank you. So let me terminate this session.